Good evening, everyone. Am I audible?
Yeah, good evening, ma'am. Yes, you're audible, ma'am.
Okay. Good evening, Naimish. So we'll wait for few more minutes, right, Amar?
Yes, ma'am. Will wait.
Then you just let me know. I
Yes,
can
ma'am.
start the session.
Yeah, sure. Yes.
Amar, I can start with the session.
Yes, ma'am. You can start.
Okay.
Yeah.
Fine. Thank you. Good evening, everyone. Okay, so today is the last session of the training. So I'll just let the agenda for today. Okay, so first we'll complete the remaining topics, okay, of day 13. So we have started with preprocessor. Okay, so small topics are remaining, okay, in that. And then we will go through the last topic, error handling. Again, a small topic, but very important topic. After that, I will be just going through the mini assignments, okay, which are shared. So everything is shared. Amar, just the today's program, which I will be sharing after the session, okay, so that you can upload. So all the assignments, okay, your complete PPT, PDF, okay, in day 15 is shared. 2 mini assignments or mini project, you can say, for the last, okay, that is also shared. So that also I will be explaining. So till 8:15, okay, I will cover all this. And after that, you will have the final quiz, okay, as said yesterday, right? So let's continue. So I'm going to share my screen. And let me know the screen is visible. Yeah. Okay. So the screen is visible. Yeah. Okay, fine. So we started with the C preprocessor. Okay. We already know what is hash include. Okay. What is hash define. And these are the preprocessor actions. Okay. Which we have already used. Now there are few others. Okay. The programs are already with me. I'm going to explain and run that programs. Okay. So there are some stages in pre-processing. First is the file inclusion. Okay, then we have got the macro expansion, conditional compilation. Okay, so last session we had just gone through this slide, and there are some miscellaneous directives. Okay, so now one by one I'll go through this, and there are the files created which I am going to compile and execute. Okay. Now, first is the header file. So we already used, okay, some of the header files in our all the programs, okay, but then we can also create our own header file. Okay, so like this is the name of the file, myheader.h. Now, whenever you create your own file, that has to be saved as .h extension. Okay, include that in double quotes. Okay. So here, this stdio.h, okay, it is the predefined, the header file, okay, which is used in every program. Then my header.h, this is the header file which is created, user defined. So it is going to be searched in the current directory first. And these are the common headers, okay, which we have used earlier, right? So this is one. So we will see one demo in which I have included the macros also. So when you create your own user defined header file, you need to save that header file as .h. Okay. Now coming to the macros. See, already we have done with the macros. Okay. Macros are code replacements done by the preprocessor before compilation. So we have got object like macros replaces a name with a value. Okay, like we have done with hash define. So hash define is what? This is a macro. Okay, so this pi is going to be replaced with this in your entire program, wherever pi is used, correct? So that is the object like macros. Then there is a function like macros, okay, which looks like a function. So macros that look like functions but are expanded inline. Then multi-line macros. Use slash to continue on next line. Okay, so multi-line means what? You need to write multiple lines, okay, of the code. So that is a multi-line macros, okay. So what we will do now, we will be understanding one example. Okay, so this is the myheader.h. Okay, now in myheader.h file, okay, now these are the directives. Okay, we will discuss about that. But why this is written? Include guard. Now this is known as the guard directives, which will prevent multiple inclusion. So if and def means if not defined, and define. So we have already done with the define in the constant like pi. Okay. So hash if not defined. Okay. Now this particular statement is written so that multiple inclusions of the header file is not there. Okay. Then this is the object like macro hash define pi 3.14159. Okay. Now I will not use this first of all. Okay. We are going to use the function like macro. Now this is the function like macro. You're using hash define square. Now the parameter which will be passed is x. And what we need to do is x into x. Okay. We will multiply square this number. Okay. And then this is a multi-line macro. Okay. Hash define print underscore sum a and b. Now this is a slash written. Okay. So printf sum is equal to %d slash n a plus b. So what is this slash? It is nothing but used to write the multiple lines. Then this is a function prototype. Okay. Function prototype. We already did with the function. So void print circle area. Okay, this is simply the prototype, or you can say the declaration of the function given in the my header file. Okay. Now this is the end if, that is the end of your my header, this particular hash define. So you have to define the header, okay, and then if not define my header, this is guarding. Okay, so this is the end if of this particular if not defined. Whenever you're writing if, you need to end that. Okay, so this is your header file, nothing you have to do, create this. Now in the main.c, we are going to include this my header.h file. So in my header, we created the macros, we created the function, and we created, okay, the square. This is the function like macro. Okay. So in the main, first of all, you need to include the user defined header. But okay, how you need to do that? You need to write this in double quotes. Okay, you should not write this in the angle brackets. Angle bracket inclusion is only for predefined header files. Then the print circle area. This print circle area we have only declare here. Okay, so definition is given here. I can define. We are passing the radius, double area, and we need to calculate. Okay. Then in the main, I'm having the radius int n is equal to 7 using the function from header, that is a print circle area. Okay, so here we are using the function from the header file, but the definition is given here. Print using macro directly. Now there are possibility, okay, that the function macro which is written here that can behave differently. Okay, I'll come back to that. What is the safe function? So if you are using square of 7 is equal to %d, and this square 7 is defined in the header, so this 7 will be actually taken here and then return x into x. Okay, so we'll be getting 7 into 7. So I need to use this particular function. Actually, this will be getting executed. Okay, because this is not commented. But there are two ways of writing this. Okay, and then print underscore sum, that is also written in header file. So print underscore sum, so I should be getting a plus b, right? So this is what is written in the main. Okay, so one extra return 0 that I'm going to delete from here. So let us now run that. Okay, so I will be day 13 is already there. Okay, so I will go to main.c. Okay, and let us write a. Okay, so we are getting the output of all. Okay, so circle with radius 5 has area. So here we have defined the function itself and we are calling. Square of 7, I'm getting 49. Okay, so this square is nothing but a macro which is called, okay, from the my header. And the print underscore sum is also okay, was in the my header.h. Okay, so this way we are calling the function. But when it comes to the macro, okay, which is written here. So if you come to this x into x, okay, this is not safe to write. Okay, understand here what I have mentioned. If you are writing square n plus plus, okay, it will expand to n plus plus into n plus plus, which will give you a different output or undefined behavior. Okay, so the better way to write this, okay, in the my header is by using the inline int square. See, this is the safer alternative. Okay, but why? Because this will be evaluated in a different way, right? So you can also use the keyword inline. So inline int square int x return x into x. Why? Because this statement can behave differently if you are passing something like this. Okay, now let us use the printf. Okay. So now let us go back. I'm going to execute both. Okay. So now I'm getting square of 7 is 49 and square of 7 is 49. Okay. So both I'm going to get the output as 49. So remember that, okay, the option what you need to use is the inline function. Okay, so this may give you a different output. So this is one. Okay, everything I have written in the same file. Then stringizing and token pasting. This is quite simple. Turns a macro argument into a string literal, and token pasting if you go to macro. Now what is defined here? To underscore string, okay, x. Okay, so whatever parameter, okay, is passed. Now simply you need to write hash x, okay, hash x. Now what is this? It is going to give the output as a string. Now, if you consider this particular statement, okay, we are calling to underscore string, okay, and then we are passing hello world. It will print hello world. What is the difference? Understand, this is a string. Till now, what we have done, whenever we need to pass the string, we have to pass this in double quotes. Okay, otherwise this will be giving an error. But you are not passing this string in double quotes. Okay, why? Because here hash x is written. So what is the purpose of this hash x? It turns a macro argument into a string literal. So this argument which is passed, hello world, this is going to be a string literal. There is no need to write this hello world in double quotes. That is the stringizing. Okay. And what is the token pasting? It is going to you need to define, you need to declare a variable. Okay. So you need to write where 1 is equal to 100. See, you need to expand this to int where 1 is equal to 100. Okay. Now, what we have done, we have again defined a macro. So create underscore where. Okay, we are passing the name. Okay, so where is nothing but it will be going to name, and this 1 is going to go into num. Okay, now what is written here? Name to hash. So to hash is used for concatenation. So this is going to actually expand to int where 1 is equal to 100. So here int is written. So instead of creating the variable like int where 1 is equal to 7, what is written? Create underscore where, call a macro, this where this output. So these are the preprocessors which you can use in the program. Okay, so GCC string again, I'm sharing this. Okay, we have got the output as hello world. This is passed as a string. Okay, this is passed as a string. And what we are getting here 100. Okay, where 1 ka value is 100. Okay, so where 1 value is 100 here. Correct? Then we have got some predefined macros. Okay, whatever macros we had created earlier, that is user defined. Correct? Like square macro we created or print underscore to underscore. Okay, so to underscore file, it will give the current file name. Then underscore underscore line underscore underscore, this is going to give the current line number. Then date, compilation date, okay, which is going to be in string. Time, compilation time. Okay, then this is nothing but your STDC, your standard ISO standard C compliance. Okay, because the specifications which are there, okay, in C must be according to the ISO, International Standard Organization, C compliance. Okay, so it will be value 1 if it is defined according to this particular standard. Then FUNC, this is going to function name, okay, which is going to follow this convention C99, okay. Then STDC version indicates C standard version. Okay, now if this is available, okay, defined, then you will be getting the output of this. So predefined. So simply, okay, what you need to do is you need to print this, okay. But in this example, one more thing, okay, which is important for you to know is this particular function display, which is having the void return. Please understand what is the meaning of the void, okay. Void means this function, okay, is not accepting any parameter, okay, any parameter. Initially also we did this, okay, in one of the program. Now understand in C what happened in C. So this void, okay, if you are not writing this void and you are calling the display and you are calling the display and you are passing here something. Let us say I'm passing the number 10. Okay, I'm passing the number 10. Okay. We will see what is written is we'll see. So I need to print what is the file. Okay, so file. So that you will get by this predefined macro, which is known as underscore. And so you will so is my screen visible? Am I audible? Yeah, okay. So there is some network issue from my end today. Okay. So here okay, so STD or STD version also you can write. Okay. So we have got hash if, hash else, or hash end if. Okay. So first of all, run this predefined macros. Okay, just give me a minute. So we are getting compiled on November 21. Okay, file predefined macros, line number, function display. STDC is equal to 1 is defined. Okay, that it is ISO standard compliance. Okay. Now one more thing, what I have told you here is that if you are not providing here anything, display is not having any parameter, but you are passing 10, you are not getting an error. Still your program runs. Okay. So if you will specify here void, that means now you will not be able to pass any parameter. Okay. So in C, void, which is passed as a parameter to the function, means this is not accepting any parameter. Okay. So now let us go back. Now see here. Okay. Why? Because we have written void. If you don't write void and you are passing a parameter, it will still work. Okay, so remember what is the purpose of writing the void as a return type and what is the purpose of writing void here. Okay, so this is the predefined macros. Now let us come to the next. Okay, conditional compilation. Okay, conditional compilation means the code will compile based on the condition. Okay, enables compiling only certain portions of code. Useful for debugging purpose. Debugging is you need to run the program in debug to understand the output to find out the errors. Platform specific code you want to run, you want to compile your program based on the specific platform, that is the OS. And there are some other optional features. Okay. So for conditional compilation, okay, there are some directives available. Hash if, okay, and that is what we have used in the previous example. So hash if, then hash if defined. Okay, so if this macro is defined, if the header file is defined. So now we are all starting this with hash. Okay, so hash if defined, hash if not defined, hash else if, hash else, and hash end if. Okay, now all this, if you write in a program, okay, so this particular part of the program or some lines of the program which is written inside this will be compiling based on the condition what is written. Okay, so now let us understand this with one program. Okay, so here conditional compilation program is written. So let me close all this. Okay, so what is conditional compilation? Now understand here everywhere you can see there is the hash define, hash if define, all these are for conditional compilation. Okay. Now you can define these macros manually or using the -d option in GCC. Suppose if your file name is demo.c, then at runtime you can write -d debug -d version. Okay, this you can write. Otherwise, you can write in the program itself. Okay, both ways are correct. Now, if you write hash define debug, that means debugging is enabled. Okay, hash define version. So you are now defining a version for a macro which is 2. Okay, you can have any version defined here. Okay, so let me just see. Vinutna, okay, let me complete these all files I will be sharing. So hash if define and hash if not define. Okay, so there is a function void feature. So hash if define debug. So we have already defined the debug. Okay, we have defined debug. So hash if define debug, we need to printf that debugging is enabled. Hash end if. Hash if not defined debug. So if this debug is not defined, then we will be printing that debugging is disabled and end if. Okay. So this is one feature. So if you are not defining this, like if you can comment this, then you will be getting the if not defined. Okay. Then we have got all this if, else if, else, and end if. Now version check. Okay, what we have done, we have defined the version, okay, which is version 2. So now we need to check the version. So what we are using, this is a nested if else. Okay. So hash if version equal to 1. So version 1. Okay. Else if version 2, then you will be printing this statement. Else if version 3, you will be printing this statement, and end if. Okay. So this is how we write in the program also. It is the same thing. Then conditional block inside the main. Now from the main, we are calling this feature function. Okay, so if debug is enabled, we will be getting this. And we are calling the version check. Okay, we are calling the version check, right? Hash if defined debug and version equal to 2. Special case debug mode on with version 2. Okay, printf program completed. Okay, now here if you will see, the version is defined as 2 and debug is enabled. So let us say if I'm going to write the version 3. Okay, the version 3 is written, correct? So I should get advanced features enabled. Okay, and debugging is enabled. Okay, so let us check that. So if now I will go ahead and compile this conditional compilation. Okay, so what I should get, debugging is enabled, then version 3 advanced features enabled, and then I'm getting the program completed. If the version is 2, then I will get this. Okay. Similarly, let us say if this particular debug is not defined, okay, and the version is 2. So based on whatever condition specification you want to give, depending on that, you will be getting the output. Okay, look here. Debugging is disabled. Okay, I'm getting debugging is disabled because this one, and then version 2 and program completed. Okay, so what you are doing, the compilation will happen only if these particular conditions are true. Okay, so that is what conditional compilation. And finally, we have got line control and miscellaneous directives. Allow programmers to modify how the compiler reports line numbers and file names in error messages, warning messages, debug information. This is mainly caused by code generators and tools that transform the source code, and it is used in advanced debugging. Okay, so there are some miscellaneous directives like hash pragma, compiler specific instructions. Like this is the one we used for disabling padding in structure. So what we have written, hash pragma pack 1. So that was the instruction to the compiler. Okay, that padding should not be enabled. Okay, so size was whatever is the size, okay, for the members. Hash error, generate compile time error. Hash line, change line number for compiler diagnostic. And hash undefine a macro. Okay. So we have defined the macro. You can undefine a macro by using UNDEF. Okay. Now all these are some miscellaneous directives you can make use of. So the program miscellaneous directive is created. Okay. Now understand this. Again, the same thing is here, but with some more, you can say the directive. Okay. So what we are doing, we are including the macro version, which is 3. Then author is user. Okay. Now hash pragma, compiling the program. This is a custom pragma message. Understand? Pragma can also be used to give the message. Okay. Yes, Kaustav, it is. We are using printf program started. Okay. Okay. Now the compiler will believe the next statement belongs to line 500 of a file named sample file.c. So what we are using, hash line 500 sample file.c. Okay. So printf, this line is considered line number in the file name. Okay. So these are predefined macros. So this line is actually going to print the line number, and file is going to print the sample file. So this line number is given by using this hash line directive. Okay. Then we have defined the author. You need to undefine the author. So undefined author. If defined author, you will print the author name, else you will write author is undefined now. Okay, so what we did, we have undefined the author. Okay. Then if you want to display the error, if version is less than 3, okay, we have defined the version as 3. If version is less than 3, error version is too low, must be at least 3. Okay, and if. So here what we are using pragma, okay, to just give out this message. Then we are using undefined to undefine the author, which is user. Okay, and then we are also using hash line to specify that the line from the file is 500 and this should be considered. Okay. So let us now use the miscellaneous directives program. So see, understand, this is something advanced. Okay, as a developer, if you need to debug, if you need to have the conditional compilation, then you have to make use of all these preprocessor directives. Okay, but yes, creating a user defined header file is important. Okay, because that you can create, okay, to have some particular functionalities which are frequently used. Okay. So I'm getting is considered line number 500 in sample file. Okay. So I'm getting the line number as 500 by simply making use of underscore underscore line. Author is undefined now. Author is undefined because we have undefined the author and end of program. Okay. So here, if I am not undefining the author, okay, let us comment this. So you will get the author name. Okay, but if you are so we are getting now the name of the author, right? So this is what is the miscellaneous directives. Okay, so all this comes under your pre-processing. Okay, so all this topic today, whatever we have taken, okay, from the header files, creating our own header file, okay, and using the different types of the macros, object, function, multi-line, then stringizing, token pasting, okay, you can make use of this in the program. Predefined macros, if you want to get the file name, line, current date and time, okay, the function name, so you can make use of these predefined macros. Conditional compilation, okay, so as I said, if you need to only compile the specific part or portion of the code, then you can make use of this conditional compilation, useful in debugging the code. And this is the line control and miscellaneous directives. This is used in advanced debugging. Okay, but you should know that these directives are available. Okay, so this was all about the 13th chapter. Okay, what we started from yesterday. That is the dynamic memory. Okay, and preprocessor directives, right? Now coming to the last topic, okay, which is error handling. Fine. Now understand what is error handling. Okay. When we write a program, okay, we get syntax error. Okay, different type of errors are there. Okay, so every program, this we have done in the very first session. Okay, every program, every language, what we are using will be having its own grammar, vocabulary, okay, syntax and semantics to write the code. Okay, So if you are not writing the code according to the vocabulary, syntax, and semantics, you're going to get a syntax error. Okay, and you need to actually rectify that syntax error, compile time error, and then only, okay, you can run the program. Fine, that is one thing. Second is, your program is compiled properly, but you are getting a different output. Okay, not the expected output. So this is a logical error. Okay, that means your logic is not correct. Suppose you have to write a plus b and you wanted the output of a plus b, but you have written a minus b. Your logic is wrong. Correct? Just an example. Third is you are getting the error or exceptions at runtime. Means your program is compiled properly, but when you are writing a, okay, that means when you are running the program, at that time you will be getting an exception. So that is known as the runtime errors. Okay, like you cannot divide a number by 0. Any particular program you consider, dividing a number by 0 will give a runtime error that you cannot divide a number by 0 or attempt to divide a number by 0. You are trying to read from a file which is not available. You will get file not found error. Okay, that this file is not available. If memory is not available, okay, you will have the stack overflow. Like we have understood this yesterday in the case of stack. Okay, like if deep recursions you are calling, okay, or very large number you have given, okay, because stack is having a limited space, okay, then you will get a stack overflow. So these type of exceptions you will get at run time. Okay, so as a programmer, it's important, okay, for you to write a program in such a way that different types of the errors and exceptions are handled. Program is not abruptly terminating and user is getting a proper user defined message, okay, for any type of the error. Now for all this, okay, there are some error handling techniques available, okay, which you should implement in the program, right? So there are different ways, okay, whether you need to return the error code, there is an error number, there is the error message, there are the standard error, okay, different types of the techniques are available, okay. So first I will go through all this, then there is only one program, okay, which will combine all the different type of the errors and how you're going to handle them, okay, that I will be demonstrating. So if you talk about the different type of the errors, okay, syntax errors are there, okay, mistakes in the code structure. So missing semicolons, wrong keyword. So you need to rectify that, okay, because this is going to be checked at compile time. Logical errors, your program runs, but you are not getting the expected output. So you can use the assert, debugging, and careful testing, okay, line by line. Runtime errors, which you get when you execute the program, like division by 0, file not found, memory issues. Okay, you can use the return value checks, error number, p error, signal handlers. Resource error, failure to access the system resource, like memory is not available, file is not opening, file is not available. Okay, so you need to use the custom error handler, return values from malloc, calloc, realloc, and fopen. System errors can be there, which is generated by the operating system or the library itself. Like you don't have the permission, maybe sometimes to write to a file, you don't have a permission if you are saving that in the C drive in a specific folder. So you have to use error number plus P error. Programmer errors or assertions, violating assumptions made by the program, like invalid array index. So you have declared an array of, let us say, 10 elements, but you are trying to access 11th element, okay? Or null pointer dereference, okay? If you are trying to which is initialized to null, okay? So in that case, you need to make use of assert. So all these are the different types of error handling techniques given, okay? So what is this? indicate errors using special return value, example null or -1. Okay, you can use this after calling functions that can fail, like fopen, malloc, and realloc. Globe now there are some predefined error numbers available. Okay, so these are the functions you can use when functions set the error number to get the specific error codes. Okay, P error function. This is used to give the descriptive error message to the user. Using assert for debugging. And it will abort the program. Abort means it will terminate. Error handling. You can create your own custom error function. Okay, you can create your own error reporting and termination routines. Use when consistent error handling is needed across the program. Error handling in dynamic memory allocation. This we have done even in the case of files. Whenever you create a file pointer, you always check if this is not pointing to null. Okay. Whenever you are making use of the calloc, malloc, realloc, okay, you need to test that particular validation condition. So check if malloc, calloc, realloc returns null. So always check memory allocation before use. Whenever you are making use of this memory, you're making use of the pointer. Okay, always check whether it is pointing to a particular resource like file or memory, or it is null. Okay, so it should not be null, right? When you are using free, then it is deallocating the memory. Then you are going to assign the null, okay, which is not having the dangling pointer issues, right? Signal-based error handling. Handle runtime errors like divide by 0 or segmentation faults using signal. Now, for very critical runtime errors that cannot be easily predicted, you can make use of signal-based error. Now, there is a function by the name of signal. Okay, so we'll see that how it works, right? Now, all this, the error number, the P error, standard error, let us first understand that. Okay. So there is a function exit. Okay. So let us now understand this all with the code demonstration. Okay. So all the different types of the this error handling mechanisms, whatever I have told you. Okay. That all is written here. And there are some libraries which we need to make use of. Okay. So if you see in this particular program, okay, we are using this standard io.h. This is required. Then standard library, error number. This error number.h will contain the error number. String.h, assert.h for using the assert function. Signal.h for making use of the signal. Okay. So we are including these many libraries. Okay. Now, if you come to the main function, okay, if you come to the main function, so first of all, we will understand how you need to validate, how you need to handle the error in the file examples. Okay, so here there is a file pointer created and you need to open a file which is not available. So non-existent.txt is the file name given. Okay, you can give any other name. That means this needs to be open for reading, right? If pointer equal to null, always check this condition. This is very important. Okay. If the pointer is pointing to null, understand this file does not exist. Okay. P error. So what is P error? This is a predefined function available to give a user defined error message. Okay. So file opening failed. Printf error number. This is the error number, prints the error code. Okay, so there is an predefined error code available for different types of the error. Okay. Else file opens successfully, and then we have to close. And remember that the closing is also important. Okay, you need to close the pointer because it will flush the buffer. Okay, so the contents will be written, okay, or it will be read. Okay, so this needs to be also written whenever you are handling the file. Okay, so here we have p error, one function. Okay, and there is the error number. Okay, so p error is printing the system error. Okay, so this is to give a user defined error message, and this is the predefined error code available for every error, okay, which can occur. Then we have got memory allocation. Okay, now when you are implementing the memory allocation code, calloc, malloc, realloc, you need to be careful, okay? And you need to again check that it is not null, correct? So if you are using this particular malloc, okay, for the memory allocation of 5 integers. Now, I have just created this I variable because we need to run a for loop, okay? Now, if air equal to null, see, initially I'm not assigning null to air, and understand null is a predefined literal. This has to be written in capital letters only. That is what is a system defined null, okay? So if air equal to null, memory allocation failed, and then there is a function exit, which is going to take the parameter exit underscore failure constant or exit underscore success constant. That is 0 or 1. Okay, and this is going to close the program. Okay, exit the program. But if the memory is allocated, then I want to print the values. Okay, so I'm running the for loop for 5 times. Malloc, you need to free. Okay, so always free the memory. This is also what we have understood, okay, in the last session. So this is the memory allocation. Always you need to validate if you need to check that it is not pointing to null, okay. Then there is a custom error handler. Okay, I will uncomment these lines to make you understand the working. Now x is equal to -1. Okay, x is equal to -1. Now, if x is less than 0, handle error, x should be positive. Okay, now what here we are checking? We are checking if x is less than 0. Now, instead of opening the brackets here and writing some printf statement, okay, what you are doing, you are creating your own custom error by the name of handle error, and you are passing this message. So handle error is created here. Look here, void handle error, and the message is taken in this constant char message. You are using fprintf standard error. Now this std error is a standard error. Okay, like we are using the standard in. Std in is for standard input. Std out is to give the standard output on the terminal. And std err is for giving the error on the standard output, which is terminal. Okay. So custom error, I want to display this custom error message, exit underscore failure. Okay. So this is custom error. Then we have got the assert example. Okay. Now what is the assert example? Int num is equal to 10, num2 is equal to 0. Divide by 0. Now, I will uncomment this later. So, here what is done? Int result is equal to divide num by num1 comma num2. That means this divide function is created somewhere. Okay, so this divide function is created here. Okay, now what we are doing? We are using assert. Okay, assert is used for debugging purpose. Now here we are checking b is not equal to 0. If b is not equal to 0, then only a will be divided by b. But if this condition is false, like b is 0, then it is going to give the error message. Okay, so that we will see what it is. And then finally, there is a signal handling example. Now, what is written here? Okay, we have got this signal is created. Okay, look here. So very first is the signal handler, and the int signal is going to be passed here, number, and you will be getting caught signal exiting safely, exit underscore failure. Okay, so now what is this particular code? So here we are going to create this. Okay, I'm going to uncomment this, right? Now you understand. Signal, now this SIGFPE, there are certain particular constants available. This is for divide by 0. And what is this signal handler? This signal handler is created here. See, which is taking the int signal. Okay. So what is this? This is again the same thing. A is 10, B is 0. So runtime, the value is 0. We need to divide this. Now, since this A is divided by B, which is 0, it will trigger the SIGFPE at runtime. So it will go to this. This is going to get that particular signal, and you will be getting caught signal exiting safely. Okay, because you cannot divide a number by 0. If it is not 0, you will get the result. Okay, and then program completed successfully. Now, whatever I had, okay, just gone through this, there are certain things. First is, what is this exit? Okay, then what is this standard error, right? Then we have got assert, P error, error number. Okay, and this signal. Okay, let us understand this. So everything is mentioned here. So there is the exit function. Okay, now this exit function is declared in standard library.h that will terminate the program. So if there is an exception, there is an error, okay, and you have used the exit, then it is going to terminate the program. So it will take exit underscore success indicates normal termination, or exit underscore failure indicates abnormal termination or failure. So many places we are using that. So here, if the memory allocation fail, I want to terminate this because of the failure. Here also, we need to terminate this, okay, because of the failure. Correct. So you can either have a successful termination or you can have the failure termination. Then we have got standard error. Okay. Standard error stands for standard error, a predefined stream provided by C. See, for the input, we are using stdio.h. Standard in is to take the input. We are using scanf. Standard out, we are using printf to give the output onto the terminal. Similarly, the std error, standard error, points to the console. It will give the output on the console only. There is no difference in that. But it is mostly useful in writing the shell scripts. Okay. Normal output can go to a file. Error messages can go to the console or a separate file. Okay. So you can also pass this to a separate file. So we are using the standard error. Okay. In this particular example, we need to pass this to the standard error. Okay. See here. Fprintf standard error. It is nothing but giving the message again onto the console in this case. Then we have got error number. Error number stands for error number. It is a global integer variable defined in error number.h. This is the header file. Functions that fail due to system library errors set error number to a specific value indicating the type of error. So we have got your error number ENT, which is no such file or directory. Like if you need to open a file which is not available. Okay. Then we have got access permission denied. E-access permission denied. You are not authorized or you do not have the permission to read or write. Okay, not enough memory, no mem, not enough memory. Bad file descriptor. Okay, your file is not proper, descriptor wrong, file already exists. Okay, so these are some common error values. Then we have got P error. P error is declared in stdio. It is used to provide human readable error messages for failed system or library calls. Automatically fetches the error description for the current error number value. Saves you from manually converting error number codes to messages. So in the example of the file, we are using that. Okay, we are using error number. So it will print the proper error number. Okay, so key points, header is stdio, output is standard error. It will go to the standard error. Custom message string you can give. Uses print message plus system error corresponding to error number. Quick readable error reporting without manual error handling. Okay, so directly you can make use of this P error and here you can also make use of the error number. Okay, so now that we have understood all, let us compile this one by one. We will be understanding this code. Okay. So first of all, I will be commenting this part. Okay, because otherwise what will happen? You will not get the end of the program. Okay, if it is abruptly, closing. Okay. So now the final code will be day 14. Okay. And this will be your error handling .c. Okay. Now, one by one, we will be going through this and understanding. Okay. So first is this particular file error handling. Okay. And memory allocation. See, file is not available. Okay. Because this is not there. So if this is not available, what you should get? File opening failed. No such file or directory. Okay. Error number value 2. Remember, if this is W here, this file will get created. Okay, because you want to write to that file. But this is read. So in the case of read, you will be getting the error. Okay, so file opening failed. File opening failed. Okay, and then you are getting no such file or directory. It is printing the system error. What is the system error? No such file or directory. And error number. So what is the error number value? It is 2. Now, in this case, memory allocation is done. Okay, so we are getting 1, 2, 3, 4, 5 because I'm not initializing error to null. Okay, so else part is going to execute. And then we are getting what program completed successfully. Okay, but now let us make this null. Okay, so if I'm using error equal to null, that means now I have initialized this error, okay, to null. Now what should happen? Exit underscore failure. What will happen if you are using exit underscore failure? Okay, so now let us compile this. So when this file is given to you, please comment, okay, and understand by compiling one by one. So here file opening failed. So first example, though anyways it is going to fail because that file is not available. Second, now I am getting memory allocation failed. Okay, memory allocation failed. Okay. Exit underscore failure. So I am not getting program completed successfully. I am not getting program completed successfully. Okay. Then we have got, okay, let me now uncomment this. Okay, let us go to the custom error. So one by one, I will be going through. Okay. Otherwise, you will not get this particular output if it is terminating in the previous case. Okay. So now I'm getting custom error X should be positive. Okay. So it is going to which function? It is going to custom error and I'm getting message. Okay. X should be positive. That message, whatever I have passed. And whenever you're writing exit underscore failure, then you are not going to get program completed successfully because it will exit the program there itself. Okay. That is why I'm uncommenting and then I'm showing you. So this will be commented again. Now let us go to the assert example. Okay. For assert, anyways, we are calling the divide method here. Okay. So this is the divide method and here we are calling assert. Okay. So now what will happen? See here. Okay. So when you are using this assert, what you are getting? You are getting this error message. Program DC programs day 14 a.exe because this is the file which is run. File error handling.c line number 22. So there is the error in line number 22. What is line number 22? This one, 22 line number where assert b is not equal to 0. Now expression b not equal to 0. So b is not equal to 0. Not 0, then you will be getting it. Okay. So you will be getting the entire file name. Is what is an assert. Okay. And finally, we have got signal. Okay. Okay. Let us go with the signal part. This is the last part now. Okay. Now let us understand the signal. Okay. This is the last part. Signal.h that allows the program to register a signal handler. A signal is a notification indicate an event. Events include errors like divide by 0. Earlier, if you want to come out of a program which is infinitely running, okay, you press Control C. So you will come out of it and you will be getting the prompt. Or other condition like timer expiration. Okay, these are the events. Signals are a way to handle exceptional runtime events in C. Like timer. Timer is an event. Okay, so timer is expired. So that event will be raised. When you press Control C, that is an event because you are interrupting a running program. So when you are interrupting a running program, it is an event. Okay, so this should be handled. See, sometimes when you're working on a system, you will be suddenly getting a message. Okay, that this maybe your printer is out of paper or some particular pop-up message is there, right? Because of that particular events, right? Similarly, in a program, when you write a program, if there are this type of the events, this needs to be handled. Okay, so there are some events that generate a signal. So we have got all these signal. Okay, so first is FPE, that is arithmetic error, division by 0. Okay, then you have got SEGV, this is segmentation fault, invalid memory access. Then you have got the int, user interrupt. Okay, Control plus C. And this is TERMS termination request. Okay, so these are some of the signals available, events, okay, which will be generating the signal. So we are considering the first one, which is a division by 0. So here what we are doing, we are first calling the signal function by passing that event, and this is the event handler. See, event handler means the function in which you are going to handle that particular error. So it is created here, signal handler, which will be taking that signal of what? FPE, which is division by 0. Then you want to print chord signal exiting safely. Okay. Now what will happen? Int a equal to 10, b is equal to 0. When you are going to now divide a by b and b is 0 here, it will trigger this signal at runtime. Okay, and then you will be getting whatever is written there. This will not be printed because b is 0. Okay, so let us see the output. So if exit is there, then the other programs you will not get the output. Okay, that is why I'm not writing that. Okay, so let us comment this part also. Okay, so here you can use Control K to comment everything. Okay, because if this is not null, okay, then what else is there? Exit, handle error. Okay, so handle error I have commented now. Okay, so let us check. Okay, see here. So got signal 8. Okay, so signal number is 8. Okay, see here. I'm getting got signal 8. Okay, see got signal 8. So what is this particular signal number? That is 8. And I'm getting exiting safely. But let us say that if it is not, okay, so if I'm giving the number as 2 and it is not 0, you should check both true and false condition. Okay. Okay, so I will be getting result 5 and the program now is not exiting. Okay, so I'm getting program completed successfully, right? So these are the different, you can say the techniques to handle the exception. Okay, so everything is there in the same program. Okay, so once this is shared, everything is shared except today's examples, whatever I have shown. Okay, once these files are available, then you can compile and see the output, comment, okay, wherever possible, okay, to see the different output, okay, validate, okay, change the values, run again. Okay, so that you will be knowing each and every type of the exceptions here, right? Fine. Okay, so Amar, I think it is now 8:15 as you said, so you can share the
Yeah.
quiz. Okay.
Yes, ma'am. I'm sharing the quiz.
Everyone, please give the quiz now. Okay. Amar, for this is for how many questions?
30 questions, 30 minutes.
30 questions. Okay. So first you give the quiz, okay, and then we will discuss about the final project topic. Okay, last 5-10 minutes. Yes, Vinutna, today there is a quiz and that is already shared. So you can start giving the quiz. It is 30 minutes, okay? 30 minutes. Shiva, quiz link is already shared. It was shared at 8:15.
Dear students, I hope everybody submitted the assessment. So I will wait for 2 more minutes and the assessment will be closed. So if anybody is pending, make sure that you're submitting your assessment. Attendance link I already shared into the chat box. Okay, so please mark your attendance too. Thank you. Okay. Yeah, so students, coming to the certification and other things, I will just give some information about that too. Okay. So as we successfully completed this 15 days training program on 30 hours. Yes, so please wait, don't leave the session. Ma'am also wants to address. So after my talk, ma'am will address on few points. Okay. So as we successfully completed this training program, 15 days, 30 hours. So you will be receiving the certificate within 8 to 15 working days via your registered mail ID. Okay. And uh, which link you're asking for? Siri, please mention the link. Okay. So like it will hardly take 8 to 15 working days. In that you will receive your certificate to your registered mail ID. But just one thing that no, there is no link for certification. Okay. So you will receive that certificate to your mail directly. There is no any another process. Just you have to make sure that now we are already done with all these things and you already submitted your attendance every day, right? So depend on attendance. If your attendance is going to be 60 or more than 60%, you will be eligible for certificate, as I mentioned on the day one as well, right? So the test, whatever we conducted, that is just to test your knowledge. So you also got to know that actually where we are, what we have to do, right? So start taking the efforts more. So we already provided all the documentation, PPTs, PDFs, material, then all recordings also available with you. You can definitely go through that in the future as well. If you face any difficulty, if you're looking for any help from the team of Excel, definitely don't hesitate to reach out to us via edl@excel.com. Okay. And on top of it, so after 8 to 15 days, if you feel that I submitted my attendance more than 60% every day I'm attending and I'm submitting the form as well, but I'm not receiving the certificate. So in that scenario, how it will be, right? So you can just drop an email to edl@excel.com after 10 to 15 days like that. Or else today only you will drop an email and not receive the certificate, because today only we are ending the program. So it's some time taking process for the approval on the certification and working on your attendance, right? So I will receive that. How we should know in our attendance percentage less than 60%. So simple mathematics. Yeah, you know that how many sessions you attended and fill the form, right? Let's divide that 15 and multiply, you will get the percentage. So as per my understanding, it's 9 session you have to submit the attendance out of 15. So you will be eligible for certificate. It will be a 60% attendance. If you are on 8 as well, it will be 53% and you will be not eligible for certificate. Student who have attended 15 days have not registered before attending class through, like, how they will get the certificate? They will not get the certificate. You send the 3 minute late. Now link is closed, so it will not consider. But no need to worry. I learned so many concepts. Okay. Thank you, sir, and Excel team. You're welcome, Momsi, and thanks for the feedback. Any other free course? In the future, there will be a couple of courses where in a certificate, please active assessment link. So doctors are over the YouTube were not able to active that, as I already mentioned that it's closed and I given you some extra time. No need to worry. It's not compulsory to for certification. Okay. Just to test the knowledge. Okay. Tomorrow class है क्या? Tomorrow class नहीं है. Today is last day. Okay. Sure. Sir, why is not showing? No need to check on to the LMS progress part. Okay. Namira. Yes, coming to the any other free courses, I will just tag the link here. I think the upcoming month calendar is already live. If I'm not wrong, it's updated by the team. And December month we are going to have the couple of SDP and FDP. Okay, close before time. It's not closed before time. Okay, the link is posted at 8:15 and it's closed by 8:45 only. Even it's closed by 8:48. Okay, so I posted the link. So let me check on the calendar. So there is one program, DSA Master with Java, which is going to start from 1st of December, 7 p.m. to 9 p.m. Then second SDP is going to be held on cyber security. That is going to start from the 15th December. And if any faculty members are also attending that program, then there are 2 faculty development program as well. That is for faculty members only. One is a quantum computing and second one will be on a digital marketing. Okay. So that is already posted into the web page itself, the XLR registration web page. So I'm posting that link too. You can just save that and definitely you can utilize that programs too. कल लास्ट डे है क्या क्लास का? अनुष्का, आज ही लास्ट डे है. Virendra, what is your message? I not received that. You can just reshare that again. Sir, thank you for this 15 days course. I understand from the beginning. Okay, great. So ma'am, if you're there, so you can just take it forward. After that, then I will take some queries and questions.
Okay, so coming to the end of this training session, I would like to thank everyone for the participation. Okay, so before closing, Amar, I have uploaded everything, all the notes, the coding PDF, PPT, and for all day 15. And
Okay.
yes, yeah, so you can upload them on LMS because participants are asking that from where we are going to get it. Okay.
Yeah, yeah.
And everyone, yeah, from okay, from my end, I had also, shared two mini projects. Okay, one is based on ATM banking simulation system, and another is the vehicle rental management system. So this and the complete PDF of all the 15 days, okay, that has been already shared, okay, in day 15 that you will be getting. Okay. So finally, again, okay, I just want to, tell you that the technical skills, okay, will grow when you practice. Okay. So continue practicing, continue working on the assignments, okay, work on the projects. Okay. So you need to explore, you need to experiment, you need to build, okay, and you need to fix the errors. And that is how you will be learning, right? And thank you everyone again, and I wish you all the best. Thank you.
Yeah.
So Amal, you
So,
can just upload everything, okay, so that
yes,
they
yes.
can get
Sure,
it.
ma'am. So by tomorrow, I will
Yeah.
inform you to upload all the material.
Yes, sure. You can continue, Amal.
Yeah, sure. First of all, thank you so much, ma'am, for your valuable time and guiding the student on this program. So, dear participants, yes, all material will be available on a dashboard as well. Even course ends around 365 days. HSV, you can drop an email again. If it's missed, team will check on that. Okay. सर्टिफिकेट कब मिलने वाला है सर सर्टिफिकेट you will receive in 15 working days sir the other course which you mentioned can I join it's free yes so that's also free training program as I said Java and cyber security you can join that I posted the link okay sir I left bye yeah bye bye yeah if you're done if there is no any query question you guys can leave the session and it was very nice to connect every day with you and I hope you also enjoy the journey of this 15 days and you learn lots of things from the team of XLR right and definitely I will be happy to see you again in the next program so I will be again there on the 1st of December to hosting the program on Java DSA mastery with Java. Sir, are this no, that is going to be on Python. Okay, sir, can you again will you send in this? Yeah, Anushka, I said the same thing. Why to repeat that again? 15 days means 15 days. Sir, can you say again when you will send a certificate? 15 working days, guys. There is no any exact time. Okay, so it's depend on the approvals and rest of things. Okay, and just take saying that 15 days, but you will get before that only. Okay, so see nowadays you will open WhatsApp every single minute or Insta as well, right? So we have to start using the email as well. No, Virendra, it will be not hard copy, soft copy. You guys will understand the actual use of email once you start your journey in the corporate. Okay, so with your web WhatsApp, you will be opening your email as well every time continuously and checking that too, even on Saturday, Sundays too. So the certificate is provided only if we complete the project that which is given by you. No, so there is no dependency. So it's just for your reference, okay, to understand. You will only get to know that. So whatever the assignment or quizzes project we taken, right? So it's not hard and fast that we requested you to submit. But if you do that now definitely those who completed with the 100% things now so they are really understood that what we are done right if we are only just listening the class and not applying that practically that there is no use of that and the time is not done right you have everything over the LMS portal as well you can repeat that again and again we're not stopping you at all. Sir, I want AIML course that will be in the future. Okay, so you will be getting that information as well. I hope you guys are part of our Telegram community. You will be receiving the WhatsApp community too. And if you subscribe to YouTube channel, then from there as well, you will get that notification as we started the course. And We are continuously in touch with your colleges as well, where we are sharing the information. So definitely it's not going to miss from anyway. And if you miss as well, you can check the edl@textlab.com page, the web page, free course registration page. There you will find all the information. Course 2, it will start from beginning only, right? So we have mix of students. So keeping in that mind, it will start from basics. Okay, so I think that's all from this program. And thank you so much, all of you, for making this program successful with the good attendance on a daily basis, responding on a time. Thank you so much, ma'am, for your valuable guidance to the students. And thanks, and see you again to the next program. Till the time, take care of yourself, take care of your family, and always happy learning with XLR. Bye bye, guys. Thank you.
Thank you.